Good evening, everyone. How's everybody doing? Good. Fantastic. Welcome to MySec Southfield, where security gets interesting. All right, so my name is Brett Hand. I'm the Southfield director. Welcome to Southfield. We meet here every second Thursday of the month. So if you like it this month and following month. There's also other meetings that occur in the state of Michigan. If you're involved in more events, come out to MySec Jackson Tuesday of the month, that means Thursday of the month, and MySec Southfield in Grand Rapids means Thursday of the month. There's also IC Square, the North Oakland IC, City IC, Lansing IC, if you would like to organize some links, you can start hitting those. And we're currently meeting at Town Square Food and Spirits. Thank the staff for the great service in the food. They provide this room to us for free, which is a great benefit. So be kind to the staff and take care of them. And also be a part of MySec. If you have a topic for a talk, let me know what you'd like to see so we can get people in here to cover this. If you'd like to give a talk, come see me. Looking for talks for February and March. I think we have something for January already, but if you have a talk ready to go, I can shift things. We are looking for people who enjoy writing about security so we can add some more blog posts to the MySec website. If you haven't visited the MySec website, please do so. It's mysec.us. Partway down the page, you'll see an invitation for Slack. Please come join the channel. The Slack channels, we have one for Southfield, Jackson, you name it. We have a channel that's been created, as well as the B-Side channel. So B-Sides, what's tomorrow, guys? B-Sides Detroit. So the 14th, signed up, just search for B-Sides Detroit and you can find the page. It's free. Initially it's $5 just to register, but you get your money back when you show up. There is no MySec social this month because it falls on Thanksgiving, so stay tuned for the social for December. RUCTFE 2019 starts on November 23rd, which is one of the big CTF participates in. Brad, do you want to speak about RUCTF? Recording. All right, everyone at home, sorry for the technical difficulties. We'll start this all over. We have the Shifty Knowledge left with Mark Stanislav. Thank you.
Okay, good?
No, we're good.
All right, cool. Let me know if levels get kind of crazy. Start my timer again. Because I'll be here with you all 2 hours if you don't make me stop. So this presentation was built for Black Hat this year. So myself and that person's name up there, we created this presentation together. Fletcher is indisposed and probably didn't want to try to do like a multicast thing with me here. So I'm going to represent some parts he built, but again, we collaborated on this presentation for a few months. So hopefully I know it pretty well at this point. So my name is Mark Stanislav. At one point in time, I called myself head of security engineering at Duo. Now I'm the head of application security. I rose by any other name, doesn't really matter. But if you aren't familiar with Duo, you don't go to Ann Arbor ever, I guess. But I would say that we have lots of jobs openings open currently. The cool thing about a weird fiscal year that starts in August is that jobs open starting in August for the rest of the year. So we've got a lot of openings right now since we're just kind of a couple months into the year. If you've got any question about those, hit me up after. So presentation overall, a lot of it will cover things interaction part, how many people have been a software engineer at least at one point in your career full time? Okay, so a few people. How many people work with software engineers because you're a pen tester, you're an appsec, so a couple more people. So a lot of this is about understanding not what we see happen in the industry, like we see bugs, great. This is an OWASP presentation, right? So we know we see bugs, we know we keep seeing basically the same OWASP top 10 year to year. If we've really seen anything, it's that not a ton changes. So clearly the approaches we're taking might be bad. At some point we should probably consider that it's not just like people are dumb, because I hear that a lot still, which is so weird, because people that get computer science degrees from like Carnegie Mellon, I don't think they're that dumb, but they don't necessarily learn computer science security in their curriculum, right? And that's one of the gaps that we're seeing, and a lot of today's talk is really about addressing not the symptoms of the problem that we're really good at addressing in security, but actually thinking about like root causes and ways and patterns that will actually get us to a better place, rather than complaining about the state of affairs in like perpetuity. I guess I can use this sweet thing that you got me, Brett. So number one, OWASP top 10, this is ostensibly an OWASP meeting. I know there's quite a few of those now in Southeast Michigan for some reason, but maybe Unify at some point, just saying. But the general idea here, right, is most organizations that think application security immediately straight line to OWASP top 10, right? There's like a lot of organizations don't even talk about appsec, they talk about OWASP top 10. Oh, we address the OWASP top 10. Oh, we scan for the OWASP top 10. Oh, we have pen testers look at it. Like we've been doing the same like weird dogmatic thing that the OWASP top 10 is somehow going to save the world. The OWASP top 10 will never be intending to be a security framework. It is literally a list of things that people see in some not so empirical way in the industry, right? There's not this like arduous data set that's being siphoned through to come up with the OWASP top 10. A lot of it is subjective. A lot of it is anecdotal. A lot of it's a couple experts that are not necessarily wrong, but this isn't some comprehensive thing that every single 2 to 3 years when they release the new top 10, that there's this exhaustive sense of what the industry looks like in practice. And we'll look at some other data from another source that actually has maybe more empirical kind of foundations. But if your organization talks about the OWASP top 10 as appsec, you're missing the boat on what appsec actually is. We'll talk about that more today. What you should know about the OWASP organization is the OWASP organization is not just a stupid top 10 list every 3 years. OWASP as an organization, much like these meetings are here to advocate, actually have a very robust ecosystem of projects. Most of these projects are way more important than the OWASP top 10 will ever be, because they actually educate engineers, they provide opportunities to share kind of actual structured frameworks. So things like ASVS, which, there's a mobile one now, and there's kind of the generic one. These are more of the kind of checklist approach to this certain vulnerability class in this certain context is a problem and you should check for it, and here's like some validation criteria. The way that people use the OWASP top 10 is actually what ASVS intends to do, right? It's actually a more comprehensive, in-depth kind of catalog of vulnerability classes in practice against a certain context or implementation. There are also things like dependency check and other like free open source things that you might have commercial products of, or maybe know about commercial products like Black Duck or SourceClear. So the takeaway here is if you're trying to educate people, you can find things like Juice Shop, which is actually a pretty robust and mature project at this point for kind of like learning as a developer what vulnerabilities look like in practice in software, like how to identify them and how to be aware of them. So if you're thinking about OWASP, reframe your perspective a little bit, that it's an organization that's been going on for dozen plus years or more. They have a lot of projects that you probably have never heard about. So I would ask you, if you take nothing else away, to start your night, end with tomorrow at work or after B-Sides maybe is more fair. Take a look at all the projects they do have and think about how those might fit into the composition of your organization. Ignore the top 10 because that's actually more hurtful than it is helpful, I think, as an industry. Veracode are, one of the kind of like longer tail InfoSec, especially AppSec kind of companies out there. They put out a lot of data out. One of the things to think about is when you see and hear OWASP top 10 come out of people's mouths by rote, they often say this thing as a parroting effect. It's not that they understand the nuance and the depth of what the OWASP top 10 intend. And this is one of the challenges, one of the risks about having this kind of ingrained nomenclature where you know what to say in the room. You know to say, we scan for the OWASP top 10. You couldn't tell me what that vulnerability class looks like in your project, but you know that if an auditor's there, if your InfoSec team's there, if you're on the InfoSec team or you're talking to a developer, they know that you want to hear those words. But the rigor to which you actually validate that thesis that they understand what the OWASP top 10 is or they're actually implementing it is often a bit of a departure. So OWASP top 10, 2 to 3 years is roughly the release cadence of the OWASP top 10. It's a lagging indicator. So even, again, that it's not super empirical in how it's created every couple of years, the more important thing to remember if you want to take a Wayne Gretzky quote, right? Don't skate where the puck is, skate where the puck's going. Why would you build a security program that's looking 2 to 3 years historical of risk and not look 2 to 3 years forward of risk, right? If your organization is currently doing something in whatever like ASP .NET, and now everyone's hyped up on Node.js, right? Looking at the risks of the context of 2 years ago would be kind of silly. You'd be like, oh, we should start thinking about like what are the kinds of nuanced risks of Node.js? You wouldn't think historically. You'd think about the future. But for some reason, as an industry, we get really hung up that this old data set from this kind of quasi like cabal of people that decide what the top 10 list is every few years is somehow the thing we're supposed to chase after when it's actually already happened to us, right? So it's kind of a weird kind of inverse relationship with what we do versus what we should be doing. It also doesn't really cover the depth of software, right? OWASP, the Open Web Application Security Project. While OWASP has a lot of facets to it now, right? There's like embedded and there's mobile and this and that. As an organization, OWASP top 10 really kind of still tailors to web, right? And it doesn't even tailor to, I think, the broadest sense of the word web. It's very like specific vulnerability classes that we see more common across web frameworks. So certain things like, things like XXE, right? It took many, many years, way past the point where XXE bugs were a problem. Like most people have stopped using XML. But it took so long for OWASP to catch up that XXE bugs were a thing that now that people are doing things like JSON or BC, like most people are past that in at least new applications. Obviously, like legacy is legacy, but in new applications, most people don't start doing stuff with XML day one in 2019, right? They start doing stuff with JSON or YAML or pick some other kind of document format or whatever else. It took so long for XXE bugs to even show up on the OWASP top 10, but by the time it got there, it was like, oh, yeah, I remember popping those bugs like 5 years ago, 6 years ago, 8 years ago. And now we've caught up to it, and now it's not really that relevant as much as it would have been relevant, at least, at the time that those things were really a problem. Again, most people, if you take a security training and AppSec training, it's like, we're going to teach you the OWASP top 10. usually they'll take a cut of the OWASP top 10, or they'll take like the top 1% of the OWASP top 10. And a lot of the nuance and the depth of appsec bugs, like really bad appsec bugs, yes, there are still SQL injection bugs. Yes, there's still like persistent cross-site scripting. There are bad things that happen, but that's probably, again, the wrong symptom to chase. You should be thinking about like where the depth of those vuln classes are. Because after you get your top cut of those bugs squared away by your developers, the really bad bugs, the bugs that no one notices for years and years and years and years are often like the type confusion bug, the weird esoteric SSRF bug that people thought they protected but didn't protect. It's all this extra stuff that is not going to be caught by your scanner. It's not going to be caught by your tier 1 AppSec engineer. This is going to be a lot harder to find, but we keep teaching engineers only the top 1% of this content, and then we are shocked when things go wrong after that. Great computer science programs. Anyone happen to go to any of these? Obviously from Michigan, it's a little bit less likely that some of these schools are up there, but Duo, we have an Austin office. A lot of my team is from UT Austin, great comp sci school. Other Ivy Leagues and well-known universities, great computer science lineage. All these great computer science schools, no question about that. The number of these schools that have a course required for software security, okay? So you have courses that surely are offered. People can elect to take certain courses if they want to within certain credits they have. But even these great computer science schools do not require their students to take a single dedicated course to software security. Question? Well, I taught at Eastern Michigan University 10 years ago, and I built curriculum for them. And I could do whatever I wanted in the class as long as I didn't touch a single line of the syllabus, because going through to refactor a syllabus is like going through changing the gospel. So a lot of these things are historical, like they're technical debt. Like education programs have technical debt too. In other cases, I think one of the things that we've seen more of is you might have either cross-disciplinary or kind of these hybrid educational opportunities. So good example, I guess, just going back to Eastern for a second, they have a information security program. They've had it for a long time. There was a complete wall between them and the computer science department for many, many, many years. They didn't want to play well with each other. There's like a lot of dogmatic opinions about different parts of the university. So some of that could be tailored to that as well. Ultimately, organizations that are hiring people out of these schools, I think if you did not go to one of these schools, and it's, again, 2019, and most, I think, organizations assume these students are getting some required education in software security, right? It seems like a safe bet, but it's not a safe bet. It's not happening. And unless the student really has a passion for security, they're not going to take those courses. Top 1% kind of bugs, yeah.
Not a lot of retention, not a lot of,
Yep, run SQL map, get a result, cool, done, yeah.
There's a lot of CS departments that use CS as a flag math as opposed to an engineering discipline as well.
I mean, we see that a lot of, even our peers in my staff, where, you have some people who are very, they use applications, but the security is kind of lost.
And some of this is maybe why, and again, this is like, it's, I mean, this is one of those things like I kind of hit the brake a little bit. Like the takeaway here is not like developers are dumb. It's like this got upvoted by X hundred people. Like this is a community for software engineers and developers and technical people. At some point, you question like, well, what is the source of truth? Like who's right? Who's not right? Again, this is a community in whether it's InfoSec or software engineering or whatever. You can go to a security forum right now and find some asinine bullshit that's completely wrong, right? Software developers can find some asinine bullshit that's completely wrong. Like we are not somehow exempt, and they're also not like at fault here. From the perspective of this example, wait a couple slides coming up, and you'll see where else we might be perpetuating these kinds of problems as well beyond the Stack Overflow cases, right? Hashtag, because you got to throw a hashtag in here somewhere. Hashtag DevSecOps. Software engineers are getting repurposed in a lot of ways, right? So I was kind of an early DevOps devotee. I got very into like Puppet and configuration management and orchestration. And a lot of those things, I mean, if you did Chef, you were actually writing Ruby to do Chef. If you're writing Puppet, you're writing in a DSL, but the bottom of it was Ruby. All the modules and libraries were Ruby, right? CF Engine had like Perl binding. Like a lot of this stuff it's code. Infrastructure as code is a phrase you'll hear often, right? So we've got this trend line towards infrastructure as code, taking it from just like kind of bare bones bash scripting up to this like much more like robust languages, right? We're asking developers to do a lot, right? Because they are becoming, when we hear like full stack engineer, I mean, which part, but people use full stack engineer as I'm going to make them wear like 9 hats and hope for the best, right? They're going to be the DBA. They don't know what database normalization is, but they're definitely the DBA. They're going to be the sysadmin. They don't know what Ansible is, but they're going to be, like we keep kind of pushing people to do more stuff because it's convenient, because they're in the environment, they're doing the technical stuff. Why not just ask them to do a couple more things? So you can check out some of those stats. Summation-wise, all of you have worked in or will work in some security role at some point, or a software engineer. You've been in IT, you've been in tech, you've seen these kinds of things become true, especially over the last time horizon of, let's say 10 years if you've been in the industry that long. So we basically end up with the last bullet point, which is no matter if you're in a small org or a big org, there's someone that probably is pretty smart, like they're a business manager, maybe they're a CTO, maybe 20 years ago they were the super duper IT person. But now, like most things, you transfer trust down, right? You assume the person you hired to do the job after some reasonable criteria is competent and capable and will do the right things in the right moments, right? That's how supply chains work. That's how human resources work, right? You have to put trust down a couple rungs, otherwise you get nothing done, right? You micromanage and you do all kinds of bad things. So a lot of organizations think their security is just great. 25% actually was lower than I was expecting. I thought it was going to be a much higher statistic, frankly, because there's a lot of kind of hubris, accidental hubris that people don't intend to be wrong, but we see the results in practice. Some of these things that we, again, hear parroted. One of the dangers of training people versus educating people is that when the context changes, they don't know how to adapt. When the situation's a little bit different, they don't know that little bit difference is a huge difference in practice or not that big of a difference in practice, right? So, if you've done enough with preventing SQL injection at your org, you may have told, or someone else may have said, like, hey, you're a developer, we've got a framework for you. Use the ORM, you will prevent SQL injection. There are many, many, many examples where the ORM in most frameworks do not actually prevent SQL injection. We are getting to the point where a lot of the things developers do, while it's not necessarily a bad thing that we have more developers using reasonably robust frameworks, the problem becomes that we're abstracting away the nuance of the language. And we don't understand the nuance of the language, that black box that you're doing f of x into. You're making assumptions that maybe don't have that basis in reality that you're hoping for. So there are definitely things in a lot of ORMs that will prevent SQL injection, and there are a lot of methods on ORMs that will not prevent SQL injection. Good luck figuring out which ones are which unless you dive deep into the documentation or into the structs that are actually implemented. Some of the other parts of this, I think, if we think of what is better, something like modern controls, we're going to talk about this one a little bit too, but there are, one of my least favorite phrases, one of the things that if you ever interview with me, don't say the words best practices. Best practices is this catch-all nonsense that people use when they don't have a good answer for the question. So best practices, by whom? In what context? For what purpose? By what standard? In which guidelines, right? So something that we'll talk about a little bit later was a best practice, quote unquote, and then about a year and a half later was not a best practice, quote unquote. And then which developers are actually going to get the memo that that thing we told you was super important 18 months ago is no longer super important and in fact dangerous. So stay tuned. We have, again, an evolution, or maybe it's a de-evolution. But the same way that we've kind of, a phrase I like to use at least, is we have a gentrification of security, right? The jerks on IRC when I was 14, hacking things in Where's groups, doing terrible things. That world's kind of gone for the most part for InfoSec. A lot of InfoSec, maybe some of you in the room, came by this industry very normally. You went to school, you got a degree, you got a job. you were not breaking the law at, barely after, puberty. So those kinds of things, when we see this is actually a natural conclusion of how we've decided to grow the current and future generations of security right now. We say, oh, don't worry about all this nonsense, just load this Metasploit module and you'll get a shell, right? We've, again, abstracted away the technical and the technician level knowledge of security, just like we're abstracting away the software engineer's visibility. So we say, hey, I'm a pen tester because I can load Metasploit, and we tell developers, oh, this one browser header, yeah, that'll solve cross-site scripting. Don't worry, because it says XSS in the header. Clearly, Microsoft knows what they're doing. Just use that header, it'll be fine, which, PS, does not actually work. A good example of that, Chrome basically decided to rip out XSS Auditor, which was a feature in Chrome to prevent cross-site scripting. Why? Because preventing all cases of cross-site scripting in a browser is actually a really hard problem, because the browser knows what you're loading. It does not know the context with which you are loading it and whether that's an OK or not OK thing to do. So you're trusting, again, this catch-all end state of a risk, like basically a threat of the browser is the thing that would expose that threat in practice and actually let someone do something bad to the client, the end user of that client. But the browser cannot be omniscient about the intent of anything that's coming at the browser unless it's like super egregious. And even the egregious things are sometimes a false positive, which is why the developer needs to set that control, because they understand their application inside and out, or at least should. So this is one thing that they tried. It's been there for a while, and they decided people can bypass it. It causes errors. It causes problems. People don't know what this black box is doing, right? We have the capability to do things, and an engineer might say, hey, Chrome, super big browser, lots of security controls. I'll let them take care of the cross-site scripting thing. That's not my problem anymore. So we've transferred that risk, right, to Chrome, and Chrome's saying, just kidding, LOL. HPKP. So going back to a couple statements ago, how many people even know what HPKP is? OK. HPKP was this very, very short-lived thing, as you'll see here from this exhaustive timeline, that Google effectively created RFC for. So how many people know what HSTS is? More? OK, a few more people. So the whole idea is when you go to a website, to bootstrap the fact that you should only see that website in a secure manner is basically what HSTS does. You can preload browsers. You can actually submit to browsers, the major browsers anyways, to be on the HSTS preload list, which means that your browser knows from the moment you've installed it that I should never be able to go to, let's say, duosecurity.com via HTTP. My browser will not let me do that. It will make me go to HTTPS. So that's what HSTS does. It basically forces that redirection, if you will, from the insecure site to the secure site without you as a user interacting. And it happens at the browser, not at the HTTP level between the client and the server, which is great. That helps a lot of different kinds of attacks. HPKP was taking this a step further in a lot of ways, which is there are basically cryptographic proofs that you have these public key pins for a web server. And in the case of that web server having these pins, you can assure that you're talking to the actual place you want to talk to, right? So this is actually one step further than just having HTTPS. You're actually assuring that the right certificates are being offered for the right sites, not some malicious third-party site, but the actual server that should be it. Well, that's a great idea in theory. Google chased this down. It started in Chrome. We went through this RFC period. People got hype, as most things happen in security. Everyone's like, great, more security, let's do it. So we have this person here, which is basically hey, I kind of botched this. And the thing about HPKP, HSTS, once it goes wrong, you can't fix it. If you lose the thing that generated that public key and you cannot do the pin that's there that has been sent to the browser, that's being cached in the browser effectively, if you cannot actually have the private key anymore to do the thing it's looking for the signature verification on, you cannot go to that website anymore. That website is no longer going to let you go to it. So this person, good question, back at our friends, the server fault Stack Overflow family. Good question. Probably a sysadmin, probably a web developer. How do I delist myself from this stuff? I can't do the thing with the security thing anymore. Like, that's the actual solution. Like, there's not many good solutions I can come up with other than you cannot use that domain. HSTS has an expiry. Most people set the expiry for like the max window, which is like months or something. HPKP is even less friendly than that. I don't know what the tolerances generally are on that because most people don't use it. But this is one of those things. It was like hot new security thing. Do the hot new security thing. More security. And if people did it and did not understand the potential for problems, they can lock themselves out of a domain for a very long time, if not forever. Most organizations probably cannot tolerate that, right? So again, we've got this best practice that's completely a risk waiting to happen if you don't understand the edges. So remember, about a year ago, Google was hype on this, RFC, people saying do it. Ivan Ristic, who if you don't know, he's published this amazing book on basically SSL TLS, Bulletproof TLS, I think is the name of it. Brilliant person, gives like TLS specific trainings, like he knows this space very well. About a year later, he's like, is this thing dead? Like, are we gonna do this? Scott, you might know from certain header projects that he does for security headers. 2017, so what, a year and a half or so later, hey, guess what? We're gonna deprecate this thing that we just released a year and a half ago, okay? So this is how quickly the life cycle of security goes. And if you don't have a security department, if you don't have security engineers, if you don't have expertise in-house, and you Googled the wrong page, well, I guess it was the right page at the time, on OWASP, or you went to a talk in 2015 and someone was evangelizing this crazy new awesome security control, you could have been one of these people that kind of got hosed because they didn't understand the edges of the risks of implementing the security feature. Example of kind of some of the more empirical data, again, Veracode, because they put out a lot. These data points that you see from 2011 to 2017, the one thing you'll notice mostly is that the trend line hasn't really shifted that much, like a little bit of ebb, a little bit of flow. What this should read to you is that we're not solving the OWASP top 10. Like, we're not actually fixing these problems across a 6-year time span. And this is an organization that scans software for a living, like that's their entire business model primarily, right? So for them to put this out, it's actually kind of questions like the value of their products, because then they're pointing out the holes, but there's nothing there to remediate in the life cycle here. Otherwise, that number would have reasonably dropped at least a few percentage points down rather than like kind of where we are today. HackerOne, so if you do any bug bounties, HackerOne, BugCrowd, Synac, whatever. HackerOne also puts out some great data. We'll see a couple examples today. HackerOne, again, we've been talking about cross-site scripting forever. People know about it. They know about all these different controls. We've seen XSS Auditor. There's a lot out there, but we're not fixing the problems still. So we say we understand the problems. We say we know how to hack them. But people are putting a lot more time in, like the example, like damn vulnerable web app or all these like vulnerable by design things, which we have engineers do these vulnerable by design challenges. But then the thing that's missing from those challenges is actually how to do it the right way. Right? We're teaching developers how to pen test, or we're showing them a POC that's supposed to be like compelling to them. But we're actually not providing the information on how to make them secure. Right? This feels, again, like we've missed one step, the most important step at the end, which is you can shine a light on the problem, but then what? And we don't often solve the then what, which is a huge systemic problem with security. One of many examples you probably can find. So this is just a search with MITRE for CVEs that have the word parsing basically somewhere in them. I think the trend line going up 2017, 2018, we've seen a big uptick in CVEs. So I wouldn't necessarily say take the it's not like 1-to-1, right? We've actually seen a big uptick since the CVE numbering got wider. They actually increased basically the key space, if you will, to a much larger amount. So I think some of that's relevant to that. But on the other side, when we think of things like Node.js, right, or we think of other like kind of like Ajax, if I can use the old nomenclature of the day, a lot of these back-end API-related things, right, like parsing is more of a thing than ever because we have so much data going back and forth, client-server, 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 and then add the back-end stuff that's added. We tend to do more with data than ever, right? I think that's probably a truism. Like, we do more with data than ever. We take data in from all kinds of sources. We aggregate it. We concatenate it. We parse it. So data is everywhere. One of the things you'll notice if you do work with your engineers, or if you are the engineer, think about how data is maybe gathered and stored and the interfaces with which it is displayed later. So maybe today you have a log aggregation system like a Splunk, or you've got like Graylog, or you got your Kibana stuff, right? In those cases, those interfaces today, the question isn't, can you hack one of those things because of like a lack of input or output sanitization or something. The question is, where is that data going to go in 5 years? Is some developer going to be like, hey, I really want to run a query and get like a new dashboard, and I built like this quick script, and I'm going to like pull some data in from this data source and then do something with it, right? Data is ubiquitous, and the access to data is often ubiquitous within organizations. If you have data and you store it a certain way, or you filter it a certain way, or you encode it on output a certain way, that is maybe not solving maybe that's solving today's problem, but what you cannot prepare for necessarily is what the interfaces are that tomorrow's data usage will be, right? So if you think about the risk today, that's great, but if you think about like, what are all the outputs of this data that could happen tomorrow in different ways, in weird, scary ways, that's really the problem. And I think parsing as a general area is something that I'm definitely concerned about, whether it's log data or telemetry of information or whatever else. Another good Veracode quote, which again, this is actually a senior executive over there. Again, Veracode, the people that make scanners for a living, you cannot scan your way to secure code, which is, again, it's not an indictment of their technology. Like, you can find vulnerabilities with Veracode products, absolutely. But it's a true statement. Like, you cannot scan yourself secure. You cannot solve a problem simply by acknowledging the problem's there, right? That's the part we keep somehow screwing up really badly in an industry. This presentation, Kelby Ludwig, who's now over at Stripe on their security team, he did this presentation for us 2 years ago at Black Hat. And this was an interesting thing. The super TLDR on what this thing was is SAML implementations overall. So much of SAML is like terrible things with XML, going back to XML being a dumpster fire. So SAML is predicated on XML weirdness, right? And the thing about XML weirdness is XML, there are RFCs, and the ways that certain XML parsers do things with an XML document are based on the RFCs. Sometimes, more than often, RFCs are not specific in really interesting ways. Like, they'll be very specific in some places, like pedantically specific, and there are other places that are like, do this or do this or do this. Probably everything's fine. In the case of certain XML parsers, if they managed to basically traverse the nodes of an XML document one way, your SAML implementation is totally cool, like everything's great. If it traverses it in a different way, both RFC compliant, you can now do a truncation attack against SAML such a way that you can basically have a SAML assertion signed by a principal, if you will, that's different than the actual principal. What this basically means in practice for SAML is that you can authenticate as someone else that you shouldn't be able to authenticate as. The problem with this vuln class is it's actually a vuln class. This specific type of attack had not been surfaced until Kelby did his research. And we know that for a number of reasons. Number one, we coordinated with CERT, which does multi-vendor and multi-party coordination. Number two is if you look at the names on the CVEs, OneLogin, Clever, Shibboleth, whatever that last one, Wiskundi, I don't know. And then other ones that came out after we released the research. But the problem is it's a design pattern problem that's common to SAML versus some like one-off, hey, this library's got a bug. It's not this library's got a bug. It's all of these libraries have a bug from different vendors in different products for different implementations. So it's an entire vulnerability class against SAML because of the XML parsing that's used by the SAML library. Can't scan for something like that. So I was actually in Atlanta, Georgia at, how many people know the organization FIRST, F-I-R-S-T? Okay, so FIRST is like this. No, but I was part of that when I was in high school. But FIRST is a 31, 32-year-old incident response organization. or this 2020 is going to be in Montreal, so a little bit closer. I spoke at it in Kuala Lumpur, so I had a little bit longer of a commute than Montreal. But first, when they've got all these, like, whether it's CCERT or PCERT, they actually have a whole PCERT thing, and the fact that I run PCERT at Duo, I went down to Atlanta, and it just happened to coincide with the day that we dropped this research. And so people heard about, like, I heard some chatter, and I was like, oh yeah, blah, blah, blah. I was like, any questions? They're like, oh, no, we're good. I was like, oh, cool, like, your engineers, that was quick, your engineers already, like, looked at this and, like, figured it out. And they're like, well, no, like, we saw your CVEs, and we don't use any of those libraries. I was like, no, like, that's not the takeaway here for you. I said, like, that's fine, like, that's good news. We did not do an exhaustive research on every sample library ever created, let alone the ones that are proprietary that we'll never have access to source code for, right? So we looked at some amount of libraries that were accessible to us within a reasonable window to do coordinated disclosure. Like, we could have done research for 2 years and not got all the libraries still. The more important part is we wanted to get the research out, the vuln class out, so that people could hopefully make themselves safe if they weren't. And I spoke to many people, and I saw, if you start looking at, like, the VU pound, which is the number that, like, kind of like the CV number, but the one that CERT puts out, there were results of people saying exactly that in the comments, like, not affected, not using that library. Okay, so if you scan with a vulnerability management tool, and you do not use one of those libraries, you will not get a hit for this vulnerability. That is not the same as you not being affected by this vulnerability. And this is the entire problem with vulnerability management tools and scanning and all these other things, is it's basically the same problem that we had with antivirus, right? Like, signature-based AV. Oh, it looks exactly like this, that's a problem. That, like, if it doesn't look like one of those, people are not going to even notice because they don't know to notice, right? They're trusting their security tool to find these things. So that's a problem. So we gotta get better at letting engineers know what they need to know sooner and more robustly than we've been doing. If you've ever wondered and wanted some empirical data to prove out this very kind of reasonable theory I think everyone holds, which is, bugs cost more if you wait to fix them versus if you fix them before you ship it code, right? Like, that's a very kind of, like, it's one of those, like, Mythbuster episodes. You're like, oh, clearly I know how this is going to play out. And then they're like, nope, bull in a china shop, totally fine. Like, the bull hanged out and it didn't hurt anything. This is one of those things that actually matched the data that we all think was already true, which is good, because that would have blown my whole world open otherwise. And despite the graph looking like it's from, like, 1992, this is just IBM. So everything looks like it's from 1992 still. Hi, IBM that is watching. So organizations that you work in, some of them may look like this. Some of them may look worse than this, more disproportionate, more proportionate. Who's to say? This is reflective of a number of my clients when I was consulting. Ultimately, I think the big takeaway is organizations have a boatload of software engineers. They've got a number of compliance people, and I don't mean that as a derogatory term, like, compliance people make things be able to get sold to markets, right? So compliance is a necessary, important part of the business. Where I think people get stuck is they go, well, compliance isn't security. Yes, thank you, we've covered that before. Compliance is important, though, to sell things that you build. So don't look at compliance people as, like, a problem. Look at them that there should be compliance people and other people, right? So you've got compliance people, you've got your software engineers, you've got a bunch of products that you sell to different markets, different contexts, different governments and private sector and all this other stuff. And then if you're lucky, right, because we know what this world looks like in other companies, you might have some pen testers on staff. Maybe those are first party, maybe they're the third parties that you bring in, maybe they're staff aug, who knows. If you're a big corporation, you probably have a bunch of people that are taking those results from Veracode, triaging them, and by triage I mean to throw them over the wall at the developer and say, fix these. And then maybe you have a couple security engineers, which I more robustly mean people that sit down with engineers and have conversations. To me, that's what a security engineer is. Understanding problems, understanding designs, understanding architectures, understanding threat models, right? Like, that's a security engineer to me. So if you're maybe even an ideal organization, depending on where you work, if an organization looks like this, and we think about, here we go, and we think about that, we can probably see there's a problem here, which is the investment where that red bar is, where everything costs a ton of money, these people are too late, right? Those people are too late to the problem. And the SaaS triage people might be on time, depending on the development life cycles and like how agile you are and some other things. But even if they're on time, the level of quality they bring to the problem is probably too low, right? They're taking results out of a system that is, again, doing some stat code analysis. It's doing some, ideally some decent parsing, maybe some like taint analysis. Like they could have a good tool, but you often don't have practitioners behind that tool to do something with that's practical or purposeful. Good example of, again, kind of a couple different empirical data sets. Number one, HackerOne. Server-side request forgery, insecure direct object reference, okay? If you're not a huge web app person yet, check those two out. I think you'll find plenty of results for both of those. Importantly, HackerOne, which again, bug bounties, pays money for bad things that are happening to people's software. Those bug bounty payouts for those two bug classes are the highest ones they offer. Every engineer we have start at Duo, we have a new hire engineer survey from my team that asks a bunch of data like, hey, what IDEs do you work in? What languages are you working on? What kind of frameworks are you working with? We really try to understand, I know this is a crazy concept, we try to understand the people that we're there to serve. So we ask them questions about who they are so that we can do better at that. But in that process, coming through the door, maybe it's a new engineer, maybe it's an intern, maybe it's a lifelong software developer, who knows, but about 2/3 of those people don't know what SSRF even is. I'm not asking about competency or can you defend it. Literally, do you know what this is? The answer is no. So that's 2/3 of the population. And then insecure direct object reference, I think they'd know it if they saw it. But again, nomenclature of these things are important because you will see those words in vuln reports, you'll see them in tool outputs. If you don't know what those words are, you actually have a learning curve to actually solve the problem because you don't understand the relationship. So yeah, sorry, half of those and then 2/3 of IDOR. So we know that the two most costly vuln classes via HackerOne data are things that our average engineer, who are, I would say better than average engineers, that when they come in the door, they don't know these things either, right? So we have a relationship where we know there's a lot of risk because the cost is high, which means the value is high. And we know people are not learning about it, whether it's in school or just their last job or however that you might learn about these things, or Stack Overflow. And then lastly, and if you're looking for one really good why Mark's so upset at the OWASP top 10, look at that one. Because again, HackerOne are real bugs in real products, real websites, real software. If there's only a 40% overlap in the issues that are in the OWASP top 10 and the actual real world accurate 2019 findings of HackerOne data, what more do you need to know? Again, this is real data versus just someone made it up one day because they felt like that was the top 10 list, right? So we know that the overlap between reality and, I guess, not reality is about 40%, right? So if we're, again, doing the OWASP top 10 and only 40% of the OWASP top 10 is in the top, percentage of HackerOne data, we know that the real world risk is not the same as the anecdotal made up kind of list. So we talked about ORMs, just a couple people kind of calling out what I said explicitly. But let's see, where's that laser thing? Here we go. Oh, is it in the middle? Boom, here we go. All right. So that top section is from the SQL injection page of Wikipedia under the subsection called mitigation. And that, as of a few months ago, was the entire section. Okay? First of all, that's the entire section. Second of all, this is actually wrong. So again, if people are trying to do some basic due diligence, love it or hate it, a lot of people look at Wikipedia as a source of truth, right? So what more specific could you ever ask for than SQL injection mitigation and get that result and not be like, okay, I got it, right? That's a reasonable outcome for an engineer to have. So whether they go to Stack Overflow or they go to Wikipedia or they go to the computer science class that doesn't have a security course, where are they supposed to be learning this stuff that we all expect them to learn after we figure out how SQL map works? Okay, that works. Another example of this kind of lagging indicator of what people need to know versus what they're learning. So two examples, one kind of I would say less popular now, but this Flask auth app that if you did much Python Flask development, you may have used at some point, may still be using. Out of the box, SHA-1, don't know how crypto happy everyone is here, but from the perspective of passwords, like not cryptographic hashes for verification kind of uses, but like password storage, it's a better than general understood rule that doing things like MD5 or SHA-1 or SHA-1 salt, not really stuff that we should do anymore. And we shouldn't have done it for a very long time. But as 2011, like this thing shipped out of the box with doing SHA-1 and calling it good. Worse off, in 2019, this not super hard to find tutorial on building this web app has JavaScript crypto doing MD5 in the browser to protect a password, and that's what it's sending over as the cryptographic hash. Again, these are not hard to find. These are things that if you were Googling around, like how do I do this thing in crypto, or how do I do this like JS thing, or how do I use this framework, you will find these results. I didn't like spelunk for these. Like they're there. It's easy to find. But since 1999 all the way to present, we've had a solution to these problems. Some are a little bit better, some are a little bit worse. Like I'm not here to like debate bcrypt versus scrypt. All that I want you to take away from this is there are solutions. They've existed a very long time, but we keep telling and parroting the same things to engineers. And again, we wonder why they're not doing the right things. In our opinion, it's because all the sources they're learning from are telling them the wrong things. So the point I was making earlier when we were kind of chatting on the side, there's a great trend in software, which is let engineers know when the components they're using have vulnerabilities. Awesome. That is great. That is visibility they have not generally had. We're seeing it with GitHub's doing acquisitions left and right. All these other organizations are making investments. The industry is making investments through VC. Software composition analysis, exposing vulnerable dependencies to developers. It's happening. So that's good. Now people can see those things. If we're showing all of this vulnerable dependency risk to these developers, and we're acknowledging that most engineers are not getting anything regarding education, whether formal education or reading websites or looking at Stack Overflow, they're going to have all these bug findings from all these packages. And what's the solution now? They don't know what to do with them. There's no context, there's no awareness. You might have a CVSS score. Most CVSS scores are as good as just making up a number. Practical reality is the way we don't want to lead is, oh, just upgrade every package. Cool, we're going to introduce regressions without understanding the consequences, and we don't understand what the risks even are to our software because they don't know what the risks are, because they don't know the vuln classes, they don't know the implementation details. We keep pushing, again, going back to like the DevSecOps, we're pushing more and more and more information to the developer's face, but there's no conduit, there's no education opportunity to understand what those things even are. And if they start talking to you, the security person, now you've got, how many people read the Phoenix Project at some point? Oh, read the Phoenix Project. If you've ever thought of like process manufacturing and stuff, like the idea of unplanned work is something as a people manager. Unplanned work is the devil. You do not want unplanned work. You want to plan your work. You don't want interrupt-driven work if it's not the job of the person, right? You want to sit people down, let them do their job, get the output, do the next thing. When you have hundreds of engineers, thousands of engineers, and maybe a couple security people, a dozen security people, right? This is not like a one-to-one thing, right? It's like very, very many to one. How many vulnerable dependencies do you think across those 1,000 engineers they're going to get in a given week? And then multiply that out by all the questions they're going to have about like, what does this mean? How bad's that thing? What's this thing? It's because we're not actually educating them. We're like whack-a-moling problems with them. Maybe they catch on like after a while through like osmosis, but that's not really the same as education, right? It's more of like the by rote thinking. Oh, last time I talked to Brad said this thing is bad. Therefore, if I ever see that again, it's bad. That's bad too. Like, what if they start, going, oh, bad, 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 but they don't really know because that one-off, that Brad, oh yeah, that's bad because X. They probably didn't hear the because X. They just heard that's bad. And now they're just going to go through the same motions every time, waste time, add regressions, break software, impact the business worse than before. Yep. If you end up anything with the night, Brad is bad is my thesis for this presentation. And then from the other side of the wall, us fine folks here, actual paraphrase enough to obscure the person who said it, because yeah, I'm too old to get into fights on Twitter. The general, again, and some of you might feel like this right now, and I'm hopeful by the end of this talk you do take away that maybe that's unwarranted, but that frustration you feel is maybe something we can project in a more positive way somewhere else. This person who said this kind of, it's a very flippant statement, I think is a nice way to put it. But it's one of the things like, okay, hey, Mark's up here, he runs AppSec, big company, whatever. I don't feel like that with my engineers when I talk to them and they don't know something, right? So where does this come from? Well, it comes from unfounded hubris. It comes from not knowing enough about the problems engineers deal with to understand and have empathy for the problems they deal with. And why might that be? Well, this person's brand new to AppSec. They've been doing it for like 6 months and somehow we got a conference presentation to talk about it. Great, that's, cool opportunity. Maybe use it differently next time. They've never been a software engineer themselves. So they're doing AppSec, but they've never written code. They've never shipped code. They've never been through SDLC at like an organization that does this. And then the last thing is a person in the audience actually asks the question like, oh, like what languages do you like to script in or program in? And they're just straight up like, well, I don't really program. And so, shrug emoji, right? That's where we end up. So even in the case where we might have people that have the title application security engineer, the engineer at least is very wrong. Like they're not an engineer clearly. The application security part is questionable at best too. But more importantly, if your engineering staff interact with someone like this, where are we going to end up, right? There's not a lot of attention or time to actually interact and have dialogue and have conversations and build rapport. And we've cut them off at like, go away, you're not smart because my scanner I've been running for like 2 weeks figured it out. I don't know how we're supposed to actually cover ground and like make progress with that kind of thing. So some of the things that we do specifically at Duo, one of the first things I did with my team is when we started the AppSec program at Duo, 2.5 years ago or so, is I started with like, what are the values that as a team we are going to fall back on when we're not sure what we're supposed to do? Like when we're not sure what the answer is, when we're not sure what our approach should be, like what are the things that are going to ground us as a team, understanding that we're in a customer service business. AppSec does not exist if there are not software engineers. There's no software to protect. So if you don't have a customer, then we all get fired at some point. So some of these things, I'm not going to go one by one, but you can probably take away the intentionality here, right? It's visibility, it's relationships, it's building understanding, it's creating trust. These are things that are foundational to all business, and somehow in security, we somehow just skip over those because of security. So as you're thinking about your teams and how you interact with your stakeholders, right? Because generically speaking, right, return on security investment, we're a cost center, all these kinds of great phrases about security investments in companies. We exist because there's stuff to protect. If the people that do the stuff that we're supposed to be there to help protect are not listening to us because they don't want to listen to us anymore because we've yelled at them or told them they're dumb, I don't know if we're really doing our job at that point. Another example of this general kind of thesis is if you think, and this is just the Microsoft security development lifecycle, so this is like a very standard security development lifecycle. A lot of people treat the SDL as the peanut butter, right? Just like slather a bunch on there, figure out what happens after that, like just do a little bit of this, a little bit of that. The way I think of it is this completely stolen off Google image search graphic, which is more of a filter for me. So we invest at the top. We invest in training. We invest in education. We invest in opportunity to make better engineers. Because weirdly enough, making better engineers scales way more than we could ever scale as a team. And then if you do all these things kind of within some proportionality down, response is like the incident response, the PSERT stuff, right? Publishing vulnerabilities that happen to your product. If you invest proportionately down the scope, you should have to do less and less and less all the way down that you can hope for, at least, better results on how few security issues you have coming out the other side. And in an organization in some cases, but in an industry that's kind of obsessed with like rock stars and ninjas, I present to the orchestra, right? People doing things at different cadences. They come in when they're needed. They get the hell out of the way when they're not. They don't, go above and beyond everyone else in the room just because they want to feel special. Like everyone's there to do something and do it well and then get out of the way and go on with your day. So when I'm talking about values like low friction, high value, there are a lot of security controls that all of us could put into place in our organization. There's so many security controls out there you can put in. The questions are like, which controls are actually impactful, right? That's a hard question to ask because you have to think about the context. You have to think about the return on that investment. You have to think about what is the friction you add to the day of an engineer if you throw 5 new AppSec tools inside of their CI/CD pipeline and you break builds every 5 minutes. Like, what is that doing for security, actually? That's a hard question to answer because most people don't take the time to ask it, right? So think about slowing down, not doing more AppSec, but doing better AppSec, or hopefully better security, period, whatever you're doing. But really think of it as the AppSec team or the infrastructure security team or the whatever team, you're there to complement the people that are on stage singing, right? You're not there to be the front of the show. You're actually there just to be like the supporting person hitting the triangle once every 5 minutes. Did I take that all the way to the end? Okay, good. So a couple other things to think about are the opportunities for interaction with your engineers as an organization. How many ways do you enable dialogue, conversation, interaction, visibility, right? Because if you're doing the once a year pen test per product, again, you're at the far right of that defect lifecycle, and you're investing a ton of money with very little return and a lot of overhead, a lot of refactoring, a lot of regression implications. So we have weekly office hours. We actually just had them today. We get in a room, we go on WebEx, and anyone can come sit down, talk to us, ask us questions, hang out, grab beer because we have beer, because cool companies have beer, I guess. We go to team meetings of engineering teams, so we actually show up, like listen to their team, like what they're working on, what their problems are, what they're worried about, deadlines, shipping dates. Again, we want like the visibility to know what's stressing them out, right? So if we bring up the topic and they're like, oh man, like, sorry, I snapped at you, this thing happened, and well, if you had maybe been in the room knowing that that thing's like about to crash into their lives, maybe you would have held off on that like priority 5 bug another day, right? So going back to the kind of the empathy, we build in-house training courses we'll talk more about. We have email, we have Slack, we have all these things. So it's about something Katie Masouras, who helped bug bounty programs, HackerOne, all these things. The whole idea of front doors, making it very easy to go the right place at the right time, right? If you don't do it, then people catch you off guard, they throw things over the wall, they hope for the best, they don't talk to you at all. So give a lot of ways to get people to let you know they need help. Because if you don't let them have those avenues, you will have bugs that are past the point of kind of no return. If you do the OWASP Top 10 training, there's your OWASP Top 10 training. Like, you're basically done, right? Your engineers, well, I can't speak for your engineers. A lot of engineers I've worked with in my career, I've been a software engineer. Most people can do these in their sleep. They know that they're doing them. They know they're supposed to do them. Most people are not learning why any of this stuff matters or how it works or why that interface does that or why the output happens. They just, again, know the by rote learning that we're teaching them over and over and over and expecting somehow like new world-changing kind of perspectives. One of our courses at Duo that we built from scratch is called Intro to AppSec. In our Intro to AppSec course, we actually talk about like what happens if you have encrypted cookies, but you don't actually have a message authentication code on the encrypted cookie. Okay? How many people in any OWASP Top 10 class have ever heard about a concept like this or taken an Intro to AppSec training or read like our Intro to AppSec course is a couple orders of magnitude harder in the general sense of the word harder than any OWASP Top 10 course you'll ever see. That's not because, again, we could not talk about the OWASP Top 10 ad nauseum. It's because we know our engineers have heard it ad nauseum, right? We want to challenge them. We want to show them things that are cool and interesting so that they're not on Slack or on Twitter 5 minutes after the class starts. These are things that are, if you've never heard of this yourself in this room right now, you're like, oh, shit, I got some code to look at when I get home. Like, these are interesting, less known issues in software, but they're prevalent in software. And it's interesting, and it's hard, and it's complex. So we get good feedback from people. We've had that number's out of date now, but we've had a lot of people take the course. The number one thing to know that we've never required attendance for any of our AppSec trainings. But I don't really, again, I don't know exact number, but something like 2/3 of all of our engineers have taken at least one of the 4 trainings we offer, and a lot of them have taken 2 or 3 of the trainings we offer. We don't require attendance. There's no mandatory annual assessment. And it's one of those things, if you don't require people to do stuff, people show up because they hear good things, right? It's word of mouth. It's awareness of, I took that course, it was cool, I learned a lot, you should take it, right? We only have people come to these courses that are often on wait lists every single quarter because people have a good experience. They actually feel like they get something out of it. And this is another one of those like, oh, wow, yeah, I guess that makes sense. If people are interested in content, they will tell people to do the thing too, versus forcing them and making them make it like a whole thing that they feel constrained and have to do. Office hours, basically TLDR is there is sometimes when people come in to sit down and ask a question, the question they came in with and the answer they left with are very different parts of the equation. We've often found kind of critical security design flaws because of a question that was asked, not about the design, not about the thing, but because we kind of like heard something that was like, oh, that's interesting, I wonder why they're doing that. And then as you dive in and ask questions and have a dialogue, you actually kind of go root cause analysis and you're like, oh, I know how you ended up here, but we actually have to backtrack this a couple layers because this is actually an anti-pattern for this thing that you want to do, right? So again, just having that front door, letting people come to you may not be the reason they came to you that day, but if you have an opportunity to interface with them, you might actually catch something that's a lot worse. We work in the developers' tools, so whether it's their issue tracker for their code bases or a wiki page or, again, their team meetings, we go where they are. If we think about education as a whole, there's this ICAP learning framework. The top most probably seems the most familiar, like watch the video on how SQL injection works. That teaches you how it works, right? Just like Masons learn how to build brick buildings by watching a video about it. So again, why we think that this is like the right way to teach anything basically in computers is beyond me. Tutorials, like cool, like you might do a tutorial, you might do the invulnerable web app, great. You probably don't have someone like leading you through. They say, hey, do that web app thing. And then cool, you learned how to exploit something, I guess. The hands-on challenges, right? So interactivity, hopefully you have a like moderator or like a kind of a TA there to help you ask questions, get dialogue, have feedback. So we get this guy very often. The fact that it says facts always makes me laugh because it's so ridiculous, like facts. So we get a lot of videos, we get a lot of like forced educational modules, not talking about our products, not talking about our web frameworks, not talking about our risks, just whatever was paid for like $5 a seat per year. Again, multiple choice quizzes, cool to memorize verbiage. Maybe you learned something, probably not, probably will not retain it. Doesn't actually apply to your job. You just know how to parrot that back when the auditor comes in the room again. Dan vulnerable web app, SQL map, gold star, right? You are now, I guess, a hacker, even though you're trying to be an appsec or a developer. I don't know why we just did that with you, but that's security, I guess. So this is the kind of thing that we keep doing is like, if you are doing pen testing for a living, good. If you are a software engineer, bad. Like this does not do anything to make you a better software engineer. Most people already knew that SQL injection existed. Clicking SQL map and passing a single parameter to it to say, this is my input field, find out how to exploit this, is not usually going to solve much for people. If you had gone to the class, you would have known. Yeah. That might go back to some of the syllabus nonsense where like one professor decided it was going to be there and the other professor decided it wasn't going to be there, and then they fought about it, and then you had it in the wrong curriculum.
You ever like had teachers before and we're no longer there, like just get rid of the creative, this is trash, or like throw a box, like hack this box, like what is happening right now?
What even are computers? So Martin, who all in all seems like a great person, currently the OWASP chairman, has been for a couple years. Again, it's yelling at people, telling them they're dumb, all these very obvious things, like if someone walked up to you in a bar, like after this with me and a beer, and you're like, Mark, that fucking sucks. I'd be like, great. I'm going to go over here. Like, it's like, why do we think in a business relationship where 9 out of 10 of these interactions are unhealthy, people are going to keep coming back to us for something? It's like, it just defies logic, but we keep trusting that people are like, well, the security team knows best. I'm going to go to the security team. Not if they're not getting good answers, not if they're not being supported or being respected, right? So a lot of these things in terms of especially the Metasploit, hey, I can hack kind of people, it is frustrating to be told that you're not smart. It's frustrating to be told that you don't know what you're doing. But it's really frustrating when the person that's telling you that doesn't have a computer science degree or a computer engineering degree. They're literally running a tool someone else built 10 years ago that automatically found the thing, but because they passed the one flag to it, they're telling you that you are dumb now. Like, that's a really hard thing to get over, I think, as an average engineer, but happens, unfortunately, as we've seen in conference presentations today. So again, we see these, again, moving the chains, giving visibility, giving awareness, great. We might be missing a couple steps here, though. So this is a very dark because I think the lighting's a little bit off here, but this is an interface. So Fletcher, he runs this company called Hunter 2. We use them at Duo. And basically the TLDR here is, use Hunter 2 or don't. Like, I think he would say use it, but I'm happy with it. Ultimately, what you should take away here is, on the left side, which is a very small view of this whole thing, but on the left side, you will see knowledge about a thing, like a vulnerability class, an attack, a kind of bad thing that happens in software. So you get the educational piece. On the right side, you can see web IDE, right? You see code. And if we saw another screenshot here, there's a terminal at the bottom as well. And the thing about connecting the dots here, and what I'll kind of end this presentation with, is providing knowledge is great, and you should provide knowledge, right? Like, tell people things, let them digest it, let them interpret it, let them hopefully ask questions to you as a security expert. That's great. That's part of learning. And then the next part is we need to let them try the thing, learn the thing, and not just like hack the thing with SQL map, but literally go into code, read the code, figure out how to exploit it directly with their hands and like typing stuff, not into a SQL map interface. And then more importantly, let them patch the code. And that's what Hunter 2 does. There's other platforms. Adversary.io does stuff like this. Secure Code Warrior does stuff like this. So again, they're not the only like thing in town, but the general, we have to let engineers be software engineers to learn software engineering better. Seems like a pretty good idea. For doing that, this is out of date now, which is good because it's already happened. Duo Security, we released 2 slide decks that we had built internally. We're kind of revamping them, reorganizing them, doing some stuff with them. So if you go to like the duo.com blog, or there's a URL in here somewhere at the end, you can get the older versions of some of the slide decks we had internally. So if you don't have an AppSec education program, if you're looking for some slideware, some fodder to start with, you get the PowerPoints, you get the PDFs, so you can like cut, paste, copy, rebrand it. It's all being released completely free. There's no licensing. There's no nonsense. So that's available. The other thing we did is we actually leveraged the platform to build our own custom modules in Hunter 2. So we open sourced the code and code knowledge, all like basically the module of the whole thing, for 6 different lessons we built internal to Duo. What we were able to do with that, so there's the stuff that we released from Duo at least. If you go to that website, I think actually community.hunter2.com works now too, but that one should work still. You will be able to get to a link where you can sign up for a completely free version of Hunter 2. So there's no license, there's no nonsense, it's just like a free version. That free version has our 6 modules loaded in there. And then if anyone else contributes to the community project for Hunter 2, Fletcher will upload those modules to the free version as well. So basically, if anyone open sources modules for this platform, you don't have to license them, you don't have to pay for them, you don't have to get seats per person. You can just sign up at that website and use them. So this is kind of the call to action, right? Is if you don't have an AppSec program, you're not happy with your AppSec program, you're tired of talking about the OS Top 10 with your engineers, we have a bunch of content we open source, both the slide deck presentation material, as well as you have a vehicle with no licensing for a bunch of content. In interactive, in browser, in IDE, in terminal, in web browser, kind of like actual, there's Docker containers back there. You actually interact with a real web server and real code. So when you make an edit in Python, it's actually the Flask app on a server that the engineer is working with one-to-one. So if you want to do some more of this, if you want to start an AppSec program, can't promise it's going to solve all your problems. Everyone's tech stacks are different, languages, all that kind of stuff. But we're really hopeful that, again, we're kind of breaking down some of the dogmatic stuff with this presentation today, giving maybe a little bit more perspective about what a healthier way of AppSec in education looks like, and then also enabling people to maybe do that as well, not just talk about it. So there's my contact details. There's the URL again. Really appreciate the time to kind of share this today. Something that clearly I feel passionate about, and something I think about a lot. If anyone has any other questions, I'm happy to answer them. Just that easy. Thanks. Appreciate it.